Good morning, good afternoon, and good evening, depending upon where you're joining us from. I'd like to introduce myself. My name is Eric Larson. I'm part of the Altair academic team, and I am beyond thrilled to welcome you to our second webinar in this series of webinars for our 2024-2025 Altair Student Contest. We have an amazing presenter today, Joshua Phillip from our academic team. He is our expert on everything data science and AI Studio, and we are thrilled to have him and have the opportunity to listen to what he has to show us. We'll get to him in just a second. Before that, I wanted to talk about our Altair student, our Global Student Contest page. High probability you've seen it already, and perhaps that's why you're here. But please make sure you check it out. That is your portal to getting us your entry. If you go to it, web.altair.com/global-student-contest-2024, and we'll make sure you get a link to that. Hop on there. You're going to get everything you could possibly need to start working on your robot optimization improvement. Opportunity to learn the software, submit your entry, information about the cash prizes, all the terms and conditions for the contest are there, and your ability to get Inspire AI Studio, PSIM, the three softwares that we're recommending most, but in reality, any Altair software will use or will work. In general, you need to improve a robot somehow, and that's pretty broad in its interpretation, whether it's structural or, as Joshua is going to demonstrate today, using data science to improve the reliability of a robot. However you want to do it, improve a robot, create a video from it, post it on some globally accepted or accessible video site, and share that link with us through the submit button, and you're on your way to hopefully winning some decent cash prizes. To assist you in using AI Studio, which is the topic of our conversation today, take a look at our academic student hub for AI Studio. Again, web.altair.com, academic-hub-AI-studio. And this is going to be everything you need specifically to get going with AI Studio. Joshua is going to show you a whole bunch of really cool information about AI Studio, and there's a whole bundle of extra material here to download the software, to learn the software, to see examples of how the software has been used, and you'll be well on your way to getting us your submission. Don't forget that the first of our quarterly submission periods is ending December 31st. Anything received before December 31st, 11:59 p.m. Eastern Standard Time is going to be considered in our first quarter, and that's always the one that's maybe a little bit less submitted to. So you always stand a much better chance to win that prize in the first quarter. But that's okay if you don't make it. Remember, we've got 2 more quarters after that. Every 3 months, at the end of that month, we're going to have for a total of 3 periods, we're going to be accepting submissions. So enter once, enter twice. We look forward to seeing your submission, seeing your entry, and seeing your video. Also, don't forget, if you're on a first team, you have the ability to request or submit a video talking about why you want Altair to sponsor you. And if you're a college or collegiate user, you can submit a video to see why we should accept you for a paid Altair ambassadorship. So that's enough of me. You're not here to see me. You're here to see Joshua. I will gladly and proudly to turn it over to him, and can't wait to see what he has in store for us. Joshua, I'm going to make you the presenter, and you take it away.
Thanks, Eric, for the wonderful introduction. And hello, everyone. I'm thrilled to welcome you to our workshop on predictive maintenance. So I work with the global academic team. Uh, I hope you guys can see my screen now. So I work with the global academic team, and I primarily work with data and analytics and mostly AI Studio. So today we are going to explore how to build a predictive model in RapidMiner to help us identify and prevent robotic failures before they happen. So let's get straight to the objective. So we are here to learn how AI Studio can help us figure out which of our robot arms might need maintenance soon. So the main goal is to prevent unexpected breakdowns and to keep our production running smoothly. So let's start by taking a look at the process. We have the data set here, and we'll have some key details about each robot arm, how much it's used, how much weight it carries, the arm reach in length, and these factors are going to help us spot potential breakdowns and our target. So we'll be focusing on the breakdown column here, which is going to tell us if a robot has failed before, and the goal is to predict the future breakdowns. So how are we going to do this? We'll start by training a model to spot different patterns in our robot data, helping us predict which robots might need maintenance soon with the help of this predictive model. And for each main prediction, we are going to get a confidence score. And this confidence score is going to tell us how sure the model is sure about each prediction. And this is going to give us a better idea of when to take action. Also, to make sure our model is accurate, we are going to evaluate it carefully. We'll use methods like cross-validation to test its reliability and check how consistently it predicts maintenance needs across different parts of the data. And this evaluation is going to help us fine tune the model and ensure it's ready for real world use. Also, we'll be using a decision tree as our model, which is going to help us see how different factors contribute to the likelihood of a breakdown. The tree visually breaks down which conditions, for example, like hours in service or maybe it's a load on the robot, are linked to higher risks. So these insights are going to guide our maintenance strategy, and this is going to help us focus on the higher risk robots. So some of the other things like why it matters, why are we doing this? So predicting breakdowns means we can focus the maintenance efforts on the robots that need it most, and we can prevent unexpected failures and keep things running smoothly. So stay tuned to see how we're going to do this in the workshop. So some of the key insights like understanding predictive maintenance. So we'll be exploring how we can predict when a machine might fail before it actually does. By using data, we can spot warning signs early and prevent costly breakdowns. We'll also see why data pre-processing is important. So before we can make predictions, we need to like clean and organize the data. So think of it like preparing ingredients before cooking. So if you don't do it right, the recipe won't turn out. We'll talk about how to get the data ready for the model to use. And also, we'll be evaluating the model's performance. So once we have a model, it's very important to check how well it's working. We don't want to trust it blindly. So we use things like accuracy and other measures to make sure our predictions are reliable and trustworthy. Uh, then we'll be definitely be doing this all hands-on example in AI Studio, which is the fun part. We'll use AI Studio to build a predictive maintenance model step by step, and by the end, you will see how easy it is to predict when a machine might fail using data. And finally, if you have any questions about anything I'm covering, feel free to drop them in the chat. I'll be happy to help. You can also check out the Alta community page anytime for more answers and resources. Okay, let's start with why we'll be using machine learning in predictive maintenance. So the first thing is we'll be learning from the past. So imagine a mechanic keeping track of how a car behaves over time, its speed, temperature, or strange noises. So machine learning almost works the same way for machines in factories or equipment in the field. It kind of looks at the past data like sensor readings and records of past breakdowns to understand how things usually work. And this helps it spot patterns and predict when something might go wrong. And the next thing is predicting problems before they happen. So just like how weather apps predict rain based on past weather data, machine learning can predict equipment issues. So it analyzes all the past data in real time and tells us if a machine is likely to break down soon. So this gives us a heads up so we don't have to wait for something to go wrong. And next thing is fixing what needs it most. So not all machines break down at the same rate. Some are more prone to issues than the others. So with machine learning, the system helps us identify which equipment is at the highest risk. And in that way, the maintenance teams can focus their efforts on the machines that need the most attention, reducing unnecessary repairs and minimizing downtime. So the big picture, by using machine learning to predict problems, companies can avoid unexpected breakdowns, save time, make sure the right equipment gets fixed at the right time. It's almost like having a crystal ball that keeps things running smoothly. So before we jump into the process, I want to talk a little bit about decision trees. Some of you might be aware what this is, some of you might not be. So it's a simple and visual way to make decisions based on conditions or questions. So imagine it like a flow chart or a series of if then choices you follow down a tree until you reach a final answer. So how do they work? We start at the starting point, that's the root node over here. So the decision tree usually starts with a question or a condition based on one of our features. So for example, is the equipment's temperature above 80 degrees? So, and then it branches down to yes or no, leads you down to a different branch, to a new question. Each branch splits based on a feature or a condition that helps separate different outcomes. For example, for example, if yes, you might go to a branch that checks another feature like is the equipment's vibration level high? If no, you might check another feature like has the machine been operating for more than 1,000 hours? So as you keep following the branches, you move from one question to the next until there is absolutely no more splitting to do. That means we'll be as we are going down, the number of samples will keep on reducing, and we'll be reaching an output that's either yes or no in our case. And each point along the way helps narrow down the possibilities and brings you closer to a decision. And at the end of each branch, you will reach something called a leaf node. So even this one here is a leaf node because this is also the end of a branch. So where the tree gives a final decision or a classification. So in predictive maintenance, this might be a label as simple as yes or no, or maybe failure expected or no failure. Okay, I hope that is clear. So if you have any questions, please feel free to drop them in the chat and we can have more discussions. Um, okay, I'm assuming that's fine. So I'll talk a little bit about the data set now, what we'll be working with. So we'll be firstly we'll be using our robot ID, which is nothing but a unique identifier for each robot in the dataset, and we'll have the arm reach in centimeters. So this could impact wear and tear. We also have payload utilization or payload in kg. These are indicators of how much the weight the robot can handle, both in proportion and actual weight. And next is the robot type. This is basically nothing but the robot's model or category. And then we have the power and base type, which is basic build and power type specifications. Uh, then I'll show you the rest of the data in the tool. So we also have hours in service. This is cumulative hours that each robot has been in operation. And we also have some other stuff like the location of the plant, the type of robot, and we also have a different usage type here. So we'll be using all of these features in our modeling. Um, and finally, last but not the least, is the DV breakdown, which we are trying to predict our target variable. So this is going to indicate whether or not a breakdown has occurred. You can see here there's no, and we also have yes. It's quite a big data set, like we have 3,871 examples. Not so big, but okay. And a robot type specifies the robot's model or category. All right. So now let's take a look at the workflow and try to understand what's happening in the beginning, and then we'll go on to hands-on examples. So firstly, we'll be retrieving the data set, and then we'll be moving on to a little bit of data pre-processing. And finally, we will have the cross-validation operator, where we'll have the decision tree models and where we're doing the performance. And then we'll have the results here. The results will be a decision tree. Uh, as you can see, I'll just minimize it. We can have the decision tree here. Also, we'll have a performance vector where we'll have all the accuracy and the other details. Also, a cross-validation test results where we'll have a confidence score and our predicted results. Okay, so now we can jump in directly to the hands-on example. So let me just start from a blank process. Uh, so let me just drag and drop my screen, and I'll just connect this here, and now we can take a look at the data set. So most of the features we already discussed. The most important one, the DV breakdown, which is our target variable. So the first thing is to set roles, especially defining our target variable and our labels. So we can do that by using the set role operator. So I'm going to just quickly drag and drop this here. So I'm going to edit this here. Okay. So setting roles in AI Studio helps the algorithm understand the dataset structure. So here is how we're going to configure this. So I'm going to choose DV breakdown here, and I'm going to use this as our label, which is our target. And also I need my ID. That's going to be robot ID, and that's going to be ID here. I click on apply. And then if I click on run, we can see that AI Studio has highlighted the DB breakdown column in green, indicating that it is the label, and the robot ID is blue, indicating that this is the ID. So this ensures that each robot is uniquely identified without contributing to the prediction. So setting roles effectively guides this algorithm and keeps the data organized for analysis. And now we can jump right into data pre-processing. So data pre-processing is always a foundational step once we have the objective. So especially in predictive maintenance, it allows us to structure and prepare our data for accurate model building. And each pre-processing step we'll cover actually plays a crucial role in ensuring that a model can handle the real world data and deliver the reliable results. So the first one which I'm going to do is handling the missing values. And I'll be doing that with the replace missing values operator. So you can see this right here. It'll be under the data cleansing part here. So I'm just going to drag and drop this over here. Yeah, so why does this matter? Why we need to replace the missing value? So a lot of real world data sets often have a lot of missing values, and this can lead to a lot of errors and inaccuracies if not handled properly. So AI Studio offers several options for filling in these gaps, ensuring a model receives a consistent output. So in my case here, just a second. Yeah. So I'll be replacing the missing values with the average. So just before that, I would like to show you something else. So if I go to the statistics tab over here, we can see the missing column over here, right? So we can see how many missing values are there. So for payload utilization, we have 6. For arm reach, we have 12. And for payload in kg, we have uh, 10. So in this data set of 3,870 examples, this is not actually a significant amount. So one way we can do this is we can probably drop all these columns. But I would like to keep them. So in that case, I'm gonna won't like to replace these missing values by their average, which is already selected in default. We also can have other options here. We can either use 0, that will also work, but I'm gonna stick with average, or we can use a value, like in case you wanna use a random value like a median or a mode or something else, you can use the value option here, but I'm gonna select average, and I'm gonna keep the attribute filter type as subset, and I'm going to select the attributes which I would like. So the ones we saw had missing values were payload in kg, payload utilization, and arm reach. Okay, so just click on apply and quickly run this. And if we go to statistics again, we can see that all the missing values have been replaced by their average values. We can't see any of these missing values here, so that means that it's been replaced. So one step is done. So missing value handling prevents the model from being biased by the incomplete data, ensuring each record actually contributes fully to the training. And the next step, which I would like to do, is encoding the categorical variables. So categorical variables in the sense, if I go to this data set here, you can see some of these columns like usage, supplier, plant, power, base, robot type, usage to, etc. So these are in categorical form and these are in numerical form. So machine learning models generally require numerical input, and we'll be using rapid minus nominal to numerical operator to convert the categorical fields. So I'm gonna quickly drag and drop in the nominal to numerical operator. Uh, so why is this important? Why do we have to do this? So in simple terms, encoding categorical variables means turning labels or categories into numbers so that a machine learning model can understand them. So in our case, for example, let's take this vendor C, vendor A, vendor B. So if we don't do this and just give the model the words directly, the model might probably think that vendor A is somehow more smaller or lesser important than vendor C, which is not true. So by encoding the categories properly, we ensure that the model doesn't mistakenly assume any order or ranking between them, and it can make better decisions without that kind of a bias. Okay, so I'll be using something called dummy encoding. We have different coding types called unique integers and effect coding here, but for this sake of this demonstration, I'll be using dummy coding. So what happens in dummy coding is, I'll show you. So we have seen this column here, how they are, right? So we have different categories under these kind of columns. So I'm just gonna like quickly run this and see what happens. So what happens is each of the single columns have been split into multiple columns. So what happens is, uh, yeah, it turns these single columns of categories into multiple columns for each category, and with zeros and ones indicating whether the item belongs to that category or not. So in this case, welding is one. That means that this column actually had welding, and that's why this welding is coming as one. And if you go over here, it's assembly is one and the rest are zeros. That means that this is this column actually had assembly. So this is dummy encoding, and this is how we can easily transform the categorical variables into a numerical format. And I would encourage you to try the other uh, encoding types as well and see if it can like improve your accuracy in any way. And this brings us to the next step, and that is normalizing the data. Uh, so I'm just going to drag and drop the normalize operator here. So normalization actually means scaling the features to a similar range. And we'll be using something called Z transformation. And this means that the entire feature will have a mean of 0 and a standard deviation of 1. And why we're doing this is it helps prevent the large range variables from overshadowing the others. And this gives all the features equal importance during the model training. So uh, if you can see here, you can see that the payload utilization is actually in a small range, like it is in decimals, and we have hours in service which is in thousands. So we don't want the model to think that this is more significant than this in any way. And to remove that kind of a bias, we are going to use normalization. So in simple terms, a normalization just adjusts your data so that all features are in a similar scale, and this helps the model perform better. And features with larger ranges like this hours in service don't dominate the learning process. So I'll just quickly run this and see what happens. You can see that all of these columns have been like converted into a similar range, right? So this gives all the features an equal chance to influence the model. Okay, so we are now actually kind of done with all the data pre-processing steps, and this is a good time to ask questions if you have any doubts regarding this. So please, you can ask the questions in the chat. I'm gonna like move this into sub-process here, call this data pre-processing.
Joshua, looks like you're doing such an amazing job. Oh, wait a second. Looks like we may have a question here. So we've got a question. Can we use this on image processing?
You mean the pre-processing steps or image processing will be different? Yeah, but sometimes we might have to normalize the data, but these kind of pre-processing steps are mostly for machine learning tasks like regression and classification. Yeah, not for image processing. It's a different way of processing the data, yes.
Okay, and it looks like he's pleased with that answer. So, Ritesh, thanks for asking your question. Joshua, great job so far.
Thanks,
Can't wait to hear
Satish.
what else you got going.
Okay, let's get back to the process so that now we are done with the model. I mean, the pre-processing, we can start with model building. Okay, and for doing that, the first thing which I would like to pull in is the cross-validation operator. So I'm gonna just quickly drag and drop that one. Uh, and I'm gonna make the important connections. So I wanna see the model output. So I'm gonna like drag and drop this as well. I wanna see the example set, and I wanna see the test result set, and I would also like to see the performance vector. So all that is connected. So a cross-validation is an evaluation method. Here we'll be splitting the data into multiple training and testing sets, and we'll be using the cross-validation to assess the model's performance on the testing data. We also have other validation methods like split validation, which also we can use, but in this case, I'll be using a cross validation. And inside the cross validation, what I would like to have is our decision tree. We already talked a little bit about the structure of a decision tree. So I'm going to drop this here. Uh, I'm going to send the model output to the testing side. And we already talked about how the decision tree is actually a hierarchical model that splits the data based on feature values and creating branches leading to different outcomes. So this is particularly useful in this the predictive maintenance problem because it provides clear and interpretable paths to predict failures based on the specific feature values which we saw earlier, like hours in service, payload, etc. And the next thing which I want to highlight is are these hype parameters on the right side. Okay, so the first thing is the criterion. So we have different criterion here. I'll be choosing something called gain ratio. So we have other criterion like information gain, Gini index, etc. And all of these are going to give you different results because all of these are different algorithms. But for the sake of this demonstration, I'll be using gain ratio. So in simple terms, I'll tell you gain ratio is a method used in decision trees to choose the best feature for splitting data. So it helps pick features that give the most meaningful and efficient splits. I would encourage you all to go look into detail how this works. It's very interesting. You can also check out the other methods here. Uh, the next thing I would like to bring to your attention is maximal depth. So the depth of a decision tree actually refers to how many layers of decisions the tree has. Okay, so if we go to our example here, uh, we can see that this has like three tests, right? So this means that the depth is 3. Okay, so the maximal depth is how many questions you're allowed to ask before stopping. So if you set the depth too high, the tree can become too complex and overfit the data. And if you set it too low, the tree might not be detailed enough. So yeah, it's a fine balance of choosing the appropriate number. So here in this example, the maximal depth is 3. So the tree will only have 3 layers of questions before it makes a final decision. Okay, so I'm going to keep everything as default. So I'm going to keep this as 10. Let's see what happens. And I'm going to keep the confidence as 0.1. And next thing which I want to bring to your attention is the minimal gain. So this is refers to the minimum improvement in the model's accuracy that is needed to justify making a new decision or a split at a particular point in the tree. So if the improvement in predicting the outcome is small, the tree won't make a split at that point. So for example, here the minimal gain is set as 0.01. So it means a split will only be made if the improvement in prediction accuracy is going to be greater than 0.01. If it's not going to be greater than 0.01, it's not going to make that split. So that's what minimal gain means. And then I would like to talk about the minimal leaf size. So this is the minimum number of data points that need to be in each final decision node of the tree. So a leaf is a final decision or classification that the tree makes. So in our case here, these are the leaf nodes, right? Okay, so minimal leaf size controls how many data points should be used to make that decision. Uh, Imagine you're making decisions based on a group of people. So if a decision or a leaf only has a very small number of people in it, it might be less reliable. So minimum leaf size says we need at least this many people in a group before we make a decision. So if the minimum leaf size here is set to 2, the tree will only create a decision leaf if there are at least 2 data points in that branch. And if there are fewer than 2, the tree will avoid making a decision there. So what you have to keep in mind is when you're going through a decision tree, the number of samples as we are analyzing, it will keep on decreasing. Okay, so that's where this kind of a thing will come in importance. Like if you're keeping it at a larger value, the tree size is actually going to be decreased. And if you're keeping it at a smaller value, the tree size will increase. Okay. And the next one is minimal size for split. This is also something related to what we are just talking about. This is the minimum number of data points required to consider making a split at the decision node. So if there are fewer data points at a node than this threshold, the tree won't split at this point and it will stop. I'm spending time to explain these parameters because this is actually gonna uh, affect our model accuracy, and you have to like play around with these values to actually find the best accuracy. So putting it all together, we have maximal depth, minimal gain, minimal leaf size, and minimal size for split. So these parameters are going to help us control the complexity of a decision tree and help prevent it from either becoming too detailed or like too simple. So it's a fine balance, like I just said. And then like we're going to have to use the apply model operator, uh, which is right over here. So I'm gonna send that here, add the modeling, and pass the testing to the unlabeled side. That's all I gotta do there. And last but not the least, I'll have to check for performance. Uh, yeah, so performance for classification, that is right here. So I'm just gonna drop this here and send this here, and yeah, the performance to the performance side and the example to the test set. And we can choose what all we need. For in my case, I'm just gonna need the accuracy and the confusion matrix, which is gonna come default. So yeah, so I think we have all the processes completely ready. So let's quickly run this and see what happens. Okay, now we have all the results. We obtain three things. One is the performance vector, the second is the cross-validation test result, and then we have the decision tree. So the most important thing first, I would like to talk about the cross-validation test result. So the model outputs different predictions, okay? It's either no or either yes. So these values here are the actual values which are already there in the data set. And these are the new predicted values which our model just predicted depending on what process we have designed. And here on the right side, we have the different confidence values. So for each prediction, this model also provides a confidence score, which is a percentage showing how sure it is about its prediction. So as you can see here, we have yes and we have no. Let's filter this for yes. And we can see all the more robots which the model has predicted that is going to break down. Okay, so if you see here, like we have one, I'm just gonna see confidence of yes also like high. So all these are high confidence, ready to break down more robots. So these are gonna need maintenance pretty soon. Okay, and we can also see the other things which are contributing to the robot breakdown, like all these values over here. I'm gonna get that into more detail when I'm gonna explain the tree. So once the model is trained, we can analyze the decision tree structure to understand the feature importance insights. So for instance, I'm gonna just turn this to tight and like zoom out a little bit. Okay. So if you see here, what is going to come in my eyes is there's a lot of hours in service, there's a lot of reach, and there's a lot of payload utilization. So this kind of suggests that older robots and robots handling more weight are actually more breakdown prone. So these insights can guide maintenance priorities and helping teams uh, guide, service the high risk robots. So let's take a look at some of the splits. So there's a yes right here. Let's see what happens. So this suggests that the supplier is from vendor A, okay? So if it's greater than 0.057, it's yes. So in this case here, if you see it's lesser than, so that's suggests a no. So here, supplier of vendor A is yes, and if the payload utilization is greater than 3.255, that suggests a breakdown. So we got to be careful in this kind of a situation. And we can also take a look in another split here. So I'm going to click on this yes here. Let's see what happens here. So the vendor is yes, vendor A is yes, and it's going down. And the payload utilization in this case is less than 3.255. And the usage is assembly, which is a no, so it's not an assembly robot. And here the arm reach should be greater than 1.535, and we have the hours in service should be less than 1.902, and the base is greater than 1.296. The hours in service greater than 0.706. So in this kind of situation also, there is a chance for breakdown. So we can actually focus on these kind of situations and, uh, you know, decide what we want to do. So each branch of the decision tree is actually giving us valuable insights, and like can see like know also why it's not having a breakdown, so we can take this kind of insights also to have some kind of preventive measures. So these kind of valuable insights showing us how specific conditions lead to different outcomes. So by following these paths, we can actually understand which phases we want to put our equipment at higher risk, and we can use that knowledge to prioritize maintenance when it's needed most. Okay, so some other key observations in the predictive maintenance model, there's always the root node of a decision tree that represents the feature or attribute that's splitting the data set in the best manner. Okay, so in our case, it's this vendor A, which is pretty significant here. So something is up with vendor A, so we got to be careful. And the first split is kind of crucial because it sets the foundation for further splits in the decision tree, helping the model progressively narrow down to more specific conditions under which failures occur. And some other important insights is model appears to evaluate reach, payload utilization, and hours in service repeatedly, showing that these features have high importance in predicting maintenance needs. And one other thing I noticed is certain plants like Ohio and Michigan have specific maintenance patterns, potentially due to difference in operational conditions. So this breakdown provides insights into how each attribute interacts with each other to influence the prediction. Please let me know if you'd like to have any further clarification on any other kind of specific branch or split. Or are there any questions? I think there are a few.
Yeah, so can I use Altair Studio? It's actually AI Studio, just for your reference if you're looking for it. Can I use Altair Studio to
Yeah.
build a machine learning model?
I mean, of course you can. I mean, we are building a machine learning model right now. So yeah, definitely you can use Altair's AI Studio to build machine learning models. And this is just one example of a model. We have so many other models here if you go here. So we can do this by logistic regression. We can either do this by neural networks. So there's so many ways to approach this problem. I'm just approaching this with a decision tree, which is also a machine learning model. So yes, you can definitely use AI Studio to build a machine learning model.
Excellent, excellent
So,
answer. That's it in the questions for right now.
okay, all right.
Look,
So,
hold on. Before you go on, looks
then,
like we got one more. Uh, what is the difference between Alteryx data analytics tool and an Altair?
okay, data analysis tool and Altair. Okay,
Yeah, Alteryx.
Alteryx. Okay. So Alteryx is a different product, and Altair AI Studio is a different product. I mean, out of courtesy for the other people in the audience, I think this is not something related, but yeah, we can definitely take this conversation outside. So, uh, yeah,
Yeah, absolutely. So, yeah, we're looking right now for questions specifically to what he's teaching. Just off the cuff, and I'm not intimately familiar with Alteryx. AI Studio with its no code, low code interface, the ability, as you saw Joshua dragging blocks on there and altering them. AI Studio is definitely recognized as the easiest, most user friendly data analytics tool. But if you're willing to post a comment or a question in our community, I'm sure we can get you some more detailed information. So community.altair.com, log in there and post it in there. But we're really looking for questions focused mostly on utilization of this tool. But appreciate the questions, keep them coming. Joshua, back to you.
yes, yes. Please ask any questions you have regarding what we are doing here, and I would be like happy to like answer. And yes, where we, yeah, we're talking about our decision trees and how we are providing the breakdown is providing insights into how each attribute is interacting with the others to influence the prediction. Okay. Now we'll have to go to the performance vector to evaluate our model. So once our model is trained and tested, we'll focus on analyzing its effectiveness in predicting when maintenance is needed. So to do this, we'll be relying on a few key evaluation metrics here. The first one is accuracy here and the confusion matrix. So each of these provides insights into different aspects of the model performance, helping us understand how well our predictive maintenance model is functioning and where there may be room for improvement. So the first one is accuracy. So I'm going to just bring my screen here, the slides, so you can see uh, the formula of accuracy. That is the number of correct predictions divided by the total number of predictions. Okay. Don't look at this now. I'll get to this a little later. So the accuracy is a measure of how often the model makes the right call. So it tells us the percentage of times the model correctly predicts whether something will break down or keep running. So in our case, the accuracy is 83.8%. So it's 83 model is 83.8% uh, like correctly predicting if the machine is going to break down or not going to break down. Okay, so uh, the accuracy alone does not tell the whole story, and that's a limitation. So for example, if the breakdowns are rare, the model might predict no failure most of the time and still have high accuracy. So that wouldn't help much in predicting actual breakdowns. And that's why we need other metrics like precision and recall to get a better idea of how the model is working. And what you can see over here, the screen, these blocks over here, is this is what we call a confusion matrix. So confusion matrix is a table that shows the counts of actual versus predicted classifications, breaking down the predictions into four categories. So we have the true positives here. Uh, so true positives is when it's actually true and predicted is true. Okay, and we also have the true negatives here that is actually true and predicted as false. And we also have the false positives here. So that is when we are predicting a failure when there is not going to be one. So that's like a false alarm. And then we have the false negatives here. It is failing to predict an actual breakdown. So this is like a missed prediction. So the confusion matrix actually allows us to go beyond the simple accuracy and understand where the model's predictions are accurate and where they may need improvement. So what we can analyze here is we have high TP and TN counts, that's true positives and true negatives. So this indicates that the model is performing well in identifying both failures and normal states. But we also have high false positive counts. So this may indicate that the model is a little too sensitive, flagging normal operations as breakdowns and leading to unnecessary maintenance. And we also have high false negatives here. So this indicates that the model might be missing the true breakdowns, and this could actually be a flaw in the predictive maintenance context. So we can actually try to change these values, and how we do this is by going back to our decision tree and playing with these hyperparameters, which I was just explaining before. So you have to like find a proper balance with these hyperparameters and see how our recall and precision, I mean the confusion matrix, is actually happening. Okay. So let's take a look at what the precision and recall means. So precision for a class actually measures how many of the instances predicted as that class are actually correct. So can calculate that by the true positives by divided by the true positives plus the false positives. Okay, so in our case for the yes class, we have a 60.67 percentage. That means that out of all the instances predicted as yes, 60.67 percentage were actually yes. And for the no class, the precision is 90.48, indicating that 90.48 percentage of the instances indicated as no were actually no. Okay, and for the recall for a class measure is how many of the actual instances of that class were correctly identified. And this is classified as the true positives divided by the true positives plus the false negatives. And if we go back, we can see that for the yes class, we have a recall of 64.78 percentage, meaning that 64.78 percentage of all actual yes instances were correctly classified as yes. And for the no class, the recall is 88.85 percentage, indicating that 88.85 percentage of all the no classes were correctly classified as no. So in this case, the model has high precision and recall for the no class, but struggles more with the S class, indicating potential issues with the false positives and false negatives for that category. And we can play around with the decision tree parameters here. So I would encourage you to definitely go and change the maximal depth, like keep try to make the tree larger and bigger, like changing these values here, and see if the recall and the accuracy is improving. So I'm sure it'll improve if you try and you find a significant balance. Uh, so yeah, that's the thing. So we are at the end of the process. So before I give the final insights, I would like to ask if there are any questions regarding the model evaluation part we are just talking about.
Not seeing anything yet. So give them just a couple more seconds here. Yeah, I think we're good on a question front if you want to wrap things up, and then I'll bring it to the end after you're done.
Okay, so I'll give some final insights. Uh, so the key takeaways which we covered were the data pre-processing, we covered handling missing values, the dummy encoding for the categorical variables, and the normalization for scaling features. So these steps are very important in ensuring the data is ready for the machine learning models. And then we explore decision trees, how key parameters like maximal depth, minimal gain, and minimal leaf size is going to help us build effective models. And then we also looked at model evaluation. We learned how we can evaluate the models with accuracy with using our confusion matrix here. And I would like to encourage all of you to like try out this on your own in AI Studio. So, and the recommended like next steps with this process over here would be like to experiment with data pre-processing, experiment with different pre-processing techniques and parameter settings to see how they can affect the model performance, and like optimize your decision trees, keep refining your decision trees by adjusting the parameters based on the data set. Then like always evaluate continuously, always evaluate your models using a variety of metrics, especially precision, recall, and accuracy, to ensure you're optimizing for the right outcome. And like finally, data science is an iterative process, and today's workshop is just a foundation in data pre-processing, decision tree modeling, and evaluation techniques. So keep experimenting, stay curious, and continue learning to enhance your skills. Uh, yeah, and to wrap up, I would like to go to the recommended next steps. So, for those involved with First Robotics, I would encourage all of you to explore our first community page and explore the engaging videos. So, I will just go here to the First Robotics page. Yeah, particularly this one by the Eagle Evolution team, where they'll be shooting short depth and tracking accuracy, which is very interesting. And also, I would like to encourage you guys to check out how we'll be using AI Studio to choose alliance partners and how we use AI Studio to analyze the Blue Alliance data. And next thing I would like you to check out is get certified in RapidMiner. So please go to the RapidMiner Academy. Uh, so you can earn a certification that teaches you how to use AI Studio in depth. It is a really fantastic way to expand your skills. We have different certification exams here, all following different uh, areas of data science. So please check it out. And last but not the least, please get started with AI Studio if you are not already using. So you can always visit the AI Studio Academic Hub page. And from here, you can easily download the software for free, and you can use it for free, and you can start exploring everything it has to offer. Uh, Yes, I think thank you guys. Thank you for like listening, and thanks for your time. We can have a final Q&A here if you have any other
Yeah.
questions regarding whatever
Looks like
we
Vivek
talked
has
about. Yes.
yeah, looks like Vivek has posted another question. If I want to use or if I want to build a machine learning model on random forest classifier, can I by using
Yes.
Altair? Are you familiar with
Yes, you can
random
definitely.
Altair?
Yeah.
Good.
Yes. And sorry, what was his name again? I'm sorry, I can't see the
Vivek.
questions.
It's Vivek.
Vivek. Okay. Vivek, fantastic question. So yeah, you can definitely use a rapid random forest operator. So if I go here, you can have a random forest right here. And actually you can use the same, you can do the same thing with a random forest, and probably you might get a better result. So yeah, definitely, like, please try it out. Yeah, you can definitely use random forest, like, in AI Studio for sure. Yeah.
Outstanding. Okay, we'll keep this open for any more questions, but lacking any, Joshua, great presentation. Really, really enjoyed it. Learned a lot from it. Those next steps are great. Make sure you take a look at the websites he pointed out. One point of clarification: you might have heard kind of an interchangeability between RapidMiner and AI Studio. Just to kind of clarify that, RapidMiner was the original name of the software, and Altair acquired RapidMiner a couple of years ago, I believe, and in the process has rebranded as AI Studio, really kind of highlighting its artificial intelligence capabilities. If you see a website with the term RapidMiner on it, or you hear us mention it, it's the same thing as AI Studio. AI Studio is the software.
Yes,
RapidMiner,
yes.
we're kind of considering the main general category. So please don't be confused by some of the websites still saying RapidMiner. It's a slow process to rebrand something. So in the
Yes, for
case that
sure.
you see RapidMiner, think AI Studio, and we'll be all be on the same page.
Yes, it's both the
Secondly,
same thing.
yeah, absolutely. So Joshua showed us an example, a great example of how to predict maintenance for a robot. This is just one of infinite choices that you could make. The contest is focusing around improvement of robotic design, and improving the reliability through predictive maintenance absolutely falls under that category. So as I had mentioned at the beginning, we got a pretty broad interpretation of improving robot design. So take this as an idea, take anything that you want, anything that uses data science to improve a robotic design, uses structural engineering or optimization, or as you'll learn in our next webinar, motor electrics, control systems to improve a robot. That's really the basics of the competition. So please take a look at the Altair student contest site. That's where you're going to find all of the information about the contest and be able to submit it. Absolutely go to that AI Studio Academic Hub site. There, we've got some great tutorials in there and great examples, as Joshua pointed out, of how AI Studio has been utilized in the past to improve robots, improve robot accuracy, I think is the Eagle evolution example there.
Yes,
But we'll leave
yes.
the question and answer period open here if there's any last questions. But other than that, Joshua, thank you so much for taking
Thanks.
the time today. I know it's pretty darn late for you, so really appreciate you taking some rather inconvenient time to educate us. This webinar, as well as the two other, the one that we did on Inspire and the one upcoming on PSIM, will ultimately end up on the student site. We're going to take these recordings and we'll put them up there, so you can always go back to this as a reference tool. So take a look there. It is a dynamic site. We're adding stuff all the time. But other than that, Joshua, I know you thank the audience. I'd like to thank them personally too for taking the time to spend some time with us and Learn
Yes.
AI Studio. Uh, Again, great presentation. Really loved it. Very informative, and really eager to see how you in attendance are going to utilize this amazing data analytics tool to improve your robot design and hopefully win some cash from us. We'll keep the questions open for a couple more
Absolutely.
minutes, but thanks again, Joshua. Great presentation.
Thanks, Eric, and thanks everyone for listening. Yeah.
Okay, I think that may be it for questions. If you have questions going forward, please go to community.altair.com. There's an academic site that you, or actually, I think there's even a student contest section in there where you can ask questions. And Joshua, myself, and some of our other experts are checking it frequently to ask your questions. That's where that's the best location for you to get your future questions
And
answered.
yes, Eric, I just wanted to say one more thing. Like here, like in AI Studio, there's if you take any operator here on the right side, you have the help section, okay, and that jumps directly to a tutorial process, and it has all the explanation you need on how to use it. So that's another way to learn. So I just wanted to add that. Okay, Eric, over to you.
Great
Yeah,
addition to the conversation,
yeah,
and a great feature in there to help you out. I know
yeah.
I'll be taking a look at that. So why don't we wrap things up here? Again, thank you so much. Thank you, Joshua. It was a great presentation. Really, really enjoyed it. And once again, I look forward to seeing all of your entries into the student contest. And we'll be announcing the first quarter winner sometime in January. Remember, deadline December 31st, 11:59 p.m. Eastern Standard Time. Uh, and we will take a look at what you have to offer. Thanks again, and be sure to attend. I believe it's next week. Sarah can correct me if I'm wrong. The PSIM webinar, which will be covering the use of electrical controls on a robot design. Thanks again, everyone.
Thank you. Bye.